Hello friends, today's question. A solid sphere of radius r has moment of inertia I about its geometrical axis. It is melted into a disk of sphere of radius small r at thickness t. If its moment of inertia about the tangential axis, which is perpendicular to the plane of the disk, is also equal to I, then the value of r is. So we have a sphere, and this sphere, solid sphere of radius r, capital R rather, is having a moment of inertia of I, and this sphere is melted into a disk which is having a radius small r and a thickness of t, and it is given that its moment of inertia about the tangential axis is also I. So we already know the formula for the moment of inertia about its geometrical axis. Moment of inertia of solid sphere about its geometrical axis and which is given as I. This is equal to 2 by 5 mr square, and let us call this as equation 1. Now this sphere is melted in the disk. Okay. You can see this sphere is melted into a disk with radius small r. Then suppose this is a disk and we have an axis which passes through its center. Let us suppose that is given as x and x prime. So moment of inertia for this disk along the axis which passes through a center and is perpendicular to this plane. So you can say thus the moment of inertia about the axis which passes through center and is perpendicular to the plane of disk. So in this case it is given as I x prime, and this will be equal to m small r square divided by 2. And if you want to find out the moment of inertia along the axis, tangential axis, so this is our tangential axis. Let us suppose this axis is given as y and y prime. So we can say moment of inertia about the axis y prime, which is parallel to axis x prime. Let us suppose that moment of inertia is given as I y prime. So in order to find out inertia y prime, we can use the theorem of parallel axis. Okay, we can say theorem of parallel axis, according to which we have moment of inertia for y prime will be equal to moment of inertia for the to which it is parallel, that is ix prime, plus the mass and the perpendicular distance square, which will be obviously the radius. And it is also given the moment of inertia for this tangential axis is same as that for your sphere. You can say, but I y prime is equal to I, which is given. Therefore, we can write this as I is equal to ix x prime plus mass radius square, and we already know the value of I as well as ix x prime. So I is from equation 1, and for ix x prime, let us call this as equation 2. Therefore, using equation 1 and 2, so from equation 1 and 2 we get I is given as 2 by 5 mr square is equal to ix prime is our m r square divided by 2 plus m r square. Here m cancels throughout, so we are left with 2 by 5 r square is equal to, now this will be equal to 3r square by 2, and solving it further, we can say our r square will be equal to, this will be 415 capital R square. Therefore, we get small r will be equal to capital R square, capital R rather, and square root of 15. Let me write it again. So from here we get r is equal to 2 upon square root of 15 and capital R. So this is our what was asked for, that the value of r. Value of r is nothing but radius of the disk. So this is the value of r, that is radius of the disk, and you can say that the option is A is the correct option. We can say option A is correct. So this completes the question. Thank you.